Quicksink, a precision-guided bomb that has the power to sink even the largest enemy vessels in minutes. But what makes this bomb truly unsettling for adversaries like China is not just its raw power. It's the speed, stealth, and cost-effectiveness with which it can be deployed. Imagine turning a billion-dollar aircraft carrier into a wreck at the bottom of the ocean with a single, well-placed strike. This is exactly the scenario the U.S. military envisions with Quicksink, a bomb that promises to complicate any naval strategy Beijing has for controlling the Indo-Pacific. The rapid expansion of China's navy has become a defining aspect of its military strategy, positioning the country as a dominant maritime force. At the heart of this strategy lies its aircraft carrier program, a crucial part of its broader ambition to establish regional naval superiority. As of now, the nation operates 3 carriers: Liaoning, Shandong, and the newly launched Fujian. These impressive vessels are clear symbols of China's determination to project power far beyond its shores. The Liaoning, a refurbished Soviet-era carrier, marked the country's first step toward creating a true blue-water navy, while the domestically built Shandong represented a major leap in naval technology. The Fujian, the most recent addition, includes advanced features like an electromagnetic catapult system, which allows it to launch heavier aircraft more efficiently. However, this is just the beginning. Beijing has even bigger plans. By 2030, it aims to have 5 carriers, and by 2035, that number is expected to rise to 6. These carriers are key to the country's goals of controlling critical sea lanes and asserting its influence throughout the First Island chain, a region stretching from Japan to Taiwan and the Philippines. Control of these waters would provide China with significant leverage over both military operations and the global trade routes that run through this crucial area. The First Island chain plays a central role in Beijing's overall naval strategy. It serves as both a line of defense and a way to exert influence over strategically vital maritime choke points like the Taiwan Strait and the South China Sea. While this region offers the ability to protect key trade routes and project power, it also exposes the country's vulnerabilities. Much of China's trade, including critical energy supplies, flows through these waters, making them potential choke points in the event of a conflict. Should hostilities arise, these routes could be easily disrupted, posing a serious threat to the nation's economic stability. To address these risks, Beijing has invested heavily not only in carriers, but also in a vast fleet of submarines, destroyers, and advanced anti-access area denial systems, including sophisticated missile technologies. The aim is to make it difficult for foreign powers, particularly the U.S., to operate freely in these waters. These ambitions put China on a direct collision course with U.S. interests in the Indo-Pacific. For decades, the U.S. has maintained a strong naval presence in the region to ensure freedom of navigation and protect allies like Taiwan, Japan, and the Philippines. The rapid growth of Beijing's navy, along with its assertive actions in the South China Sea, threatens to tip the balance of power in the region. As it seeks to establish itself as the dominant maritime force, it faces mounting resistance from the U.S., which views this expansion as a direct challenge to international norms and its own strategic interests. As Beijing continues to ramp up its naval capabilities, the U.S. must develop new countermeasures to maintain its strategic edge in the Indo-Pacific. One such tool is Quicksink, a game-changing weapon capable of turning the tide in a naval conflict and complicating the Chinese Navy's efforts to control the region's seas. Just a quick moment before we move on. If you're new here and you like this content, consider subscribing to sustain our work and help us create more videos like this. So, what exactly is a Quicksink bomb? It represents a revolutionary leap in the U.S. military's arsenal, specifically designed to boost its anti-ship capabilities. Developed by the U.S. Air Force Research Laboratory, AFRL, the concept was born in 2021 when the Air Force identified a need for a low-cost, quick-response tool that could precisely strike large enemy vessels. This system takes conventional bombs like the GBU-31 Joint Direct Attack Munition, or JDAM, and turns them into highly effective ship killers. Essentially, the bomb works by modifying the standard JDAM with advanced guidance systems, allowing for accurate strikes on both stationary and moving maritime targets. The JDAM itself is a well-established guidance kit that converts unguided bombs into precision munitions. It adds a tail section with aerodynamic control surfaces and a GPS-guided inertial navigation system. Once released, the JDAM guides itself to the target. making it reliable in all weather conditions. What makes this new system special is the sophisticated seeker technology added on top of the JDAM. This technology allows it to track and engage moving ships, something traditional JDAMs weren't designed for. The bomb uses a combination of radar guidance and infrared imaging to identify a ship's vulnerable spots and home in on them, even as the ship maneuvers through the water. This flexibility makes it far more versatile than naval weapons like torpedoes, which are typically launched from submarines or ships and have much shorter ranges. The bomb is designed to hit the hull just below the waterline, a critical area for any vessel. The damage is devastating, especially to large vessels like aircraft carriers and destroyers. The first successful test was conducted in April 2022, when an F-15E Strike Eagle deployed a modified 2,000-pound GBU-31 JDAM, successfully destroying a full-scale vessel in the Gulf of Mexico. In 2024, the system again demonstrated its devastating power during the RIMPAC, Rim of the Pacific exercise, the world's largest maritime warfare drill. A B-2 Spirit stealth bomber launched the modified bomb against the decommissioned USS Tarawa, a 38,900-ton amphibious assault ship. This marked the first public demonstration of the Spirit's ability to deploy the bomb for anti-ship missions. Given that this bomber can carry up to 16 GBU-31 JDAMs, this highlights just how much firepower a single stealth bomber could bring to a maritime conflict. Traditionally, the U.S. Navy has relied on expensive torpedoes and anti-ship missiles to take down enemy vessels, but those weapons come with a hefty price tag and limited deployment options. By contrast, this new system offers a low-cost alternative that can be launched from a variety of platforms, including fighter jets and stealth bombers. As Major Andrew Swanson, Division Chief of Advanced Programs at the 85th Test and Evaluation Squadron, put it, "Heavyweight torpedoes are effective at sinking large ships but are expensive and employed by a small portion of naval assets. With Quicksink, we have demonstrated a low-cost and more agile solution that has the potential to be employed by the majority of Air Force combat aircraft, providing combatant commanders and warfighters with more options." Let's start by looking at the cost-effectiveness. At the heart of its affordability is the use of surplus Mark 84 bombs paired with JDAM kits. The Mark 84, a 2,000-pound bomb first developed in the 1950s, is one of the most widely available munitions in the U.S. arsenal. Combining this existing bomb with a JDAM kit creates a powerful anti-ship weapon at a fraction of the cost of more advanced alternatives. A single JDAM kit costs around $25,000 to $30,000, and the Mark 84 itself comes in even cheaper, around $16,000. Together, the system can be deployed for a fraction of the cost of other munitions on the market. In comparison, traditional anti-ship weapons like the AGM-158 CLRASM long-range anti-ship missile are much more expensive. Each LRASM unit costs approximately $3.24 million, far more than a JDAM modified bomb. Similarly, Mark 48 torpedoes, the U.S. Navy's go-to for sinking enemy ships, cost about $4.2 million per unit. These weapons are undoubtedly effective, but their high cost means fewer can be produced. In contrast, this more budget-friendly system offers a scalable solution that can be fielded in larger numbers. Beyond the cost savings, this system also offers exceptional flexibility in how it's deployed. While traditional naval weapons like the Mark 48 torpedo are restricted to submarines, and the LRASM needs specialized platforms such as FA-18 Super Hornets or B-1B Lancers, this new system can be launched from a wide range of aircraft. This includes platforms like the F-15E Strike Eagle and the B-2 Spirit, with the possibility of future integration into advanced fighters like the F-35. Being able to launch from so many platforms provides the U.S. military with enormous flexibility when carrying out maritime strike missions. While this new bomb offers a promising solution for the U.S. military's maritime strike capabilities, it does come with its share of challenges and limitations. First up, there are air defense concerns. In a potential conflict with near-peer rivals like China, deploying such weapons becomes trickier due to the advanced air defense systems these nations possess. Beijing, for instance, has developed a formidable network of coastal defense systems, including long-range surface-to-air missile systems like the HQ-9 and S-400. These systems can target aircraft at ranges exceeding 200 kilometers, creating a highly contested environment where even stealth planes need to tread carefully. China's modern destroyers and cruisers are also armed with advanced anti-aircraft defenses, making it even harder for U.S. aircraft to approach safely and deliver these bombs. In situations like this, any aircraft launching an attack would need to skillfully navigate through layers of enemy defenses, relying heavily on stealth or electronic warfare support to avoid detection and minimize the risk of engagement. To counter these hurdles, the system would likely be deployed as part of a larger coordinated strike package. This would involve the use of electronic warfare, decoys, and other assets designed to weaken or neutralize enemy air defenses before engaging critical maritime targets. However, the risk remains high, especially when dealing with sophisticated adversaries equipped with integrated defense networks. Another challenge is the weapon's relatively short range when compared to other naval options. The standard JDAM used has an effective range of around 28 kilometers, about 17.5 miles, while the extended range version, JDAM-ER, can reach up to 75 kilometers, approximately 46.5 miles. While this is fine for many tactical scenarios, it requires the launching aircraft to get fairly close to the target. In heavily defended environments, this proximity increases the risk for both the aircraft and the crew. However, the risk is reduced somewhat by using stealth platforms like the B-2 Spirit, which can avoid detection and deliver these precision bombs with minimal exposure to enemy defenses. Looking to the future, the ability to deploy this bomb on new platforms will greatly enhance the U.S. military's anti-ship capabilities, especially with advanced technologies like the B-21 Raider on the horizon. Set to be the next-generation stealth bomber for the U.S. Air Force, the B-21 won't just replace the B-2 Spirit. It's expected to significantly boost the U.S.'s capacity to deliver precision strikes over long distances. With an open systems architecture, the new bomber is designed to seamlessly integrate with a variety of current and future weapon systems, including this cutting-edge bomb. As more Raiders are introduced in the 2030s, their ability to deliver precision strikes will greatly expand the U.S. military's maritime strike options. Thanks to its stealth capabilities and global reach, the deployment of these bombs will become even more flexible and far less risky. This will allow U.S. forces to target enemy ships deep within contested zones without worrying about being detected. The Air Force is projected to build 100 to 200 B-21 bombers, giving it a formidable platform to deliver anti-ship strikes in key strategic areas like the Indo-Pacific. Beyond the B-21, fighter jets like the F-35 Lightning II could also be equipped with smaller versions of the system, further increasing flexibility in combat operations. With its stealth and advanced sensor systems, the F-35 would allow for quick, close-in strikes against enemy ships, even in high-risk environments. As the global balance of naval power continues to shift, the introduction of innovative tools like Quicksink could very well reshape the dynamics of maritime conflict. With its ability to strike large enemy vessels swiftly and cost-effectively, this innovative weapon provides the U.S. with a vital edge in the increasingly contested waters of the Indo-Pacific. But beyond its tactical advantages, the bomb sends a clear message. The days of relying on traditional and costly naval weapons may be numbered. Will adversaries like China rethink their ambitions to dominate the seas, knowing that their carriers and destroyers could be turned into underwater wreckage in a matter of minutes? Or will this provoke an even greater arms race, with each side developing newer and deadlier technologies to outmatch the other? One thing is certain: Quicksink is a powerful reminder that in the high-stakes game of naval warfare, the rules can change in an instant.